Hey, what's going on, guys? So, what this video is, it's the first video in solving linear inequalities in absolute value. Now, we just finished the whole entire chapter on solving equations. Now we're going to get into solving inequalities, which are a special type of equation. And before we get into that, I just want to go over some word problems so you can kind of see what an inequality really is, and the difference between an inequality and an equation. So, if we're talking about here, we have a kid named Rob, and he's trying to score the most goals in a single season for his soccer team. So far, he has 9 goals, okay? And the record is 21 goals. This is the record, all right? Let's say if he just wants to tie the record and he has 6 games left, how many goals must he score per game to tie the record, all right? So basically, what we have to do here is we have to know that he has 9 goals so far. By the end of the season, he needs to have 21 goals, and he has 6 games left. All right. So basically, if he just wants to tie the record, there's only one number that will give him that answer. Okay. And basically, the way you would do this is if he has 21 goals. Well, if he wants 21 and he already has 9, we need to find out how many more does he have to score. So, well, we're going to do 21 minus 9. It's going to give us 12. So he still needs 12 goals to beat the record. Okay? We just need to know how many goals must he score per game to tie the record. So on average, if there's 12 goals left for him to win the record, or to tie the record, and he has 6 games left, let's see. If there's 12 goals, the goals per game, we must divide that by 6 games. So therefore, he needs to score 2 goals per game. Simple enough, right? All right, so basically, he needs to score 2 goals per game to tie the record at 21. Now, the way we just solved that problem was very, very basic, all right? There was no algebra involved. At least that's what you think. But in reality, you did actually solve an equation. We just didn't write it that way. So the way you would have written that as an equation is, what does our end goal need to become? Okay, so we need to score 21 total goals. We want that to be equal to, so this is the record. Okay, we need the record to be equal to season goals. All right, and this is why kids don't like solving equations or creating equations, because this above method was very, very simple. Setting up the equation is a little different. All right, so the record is 21. And that's going to be equal to the amount of season goals. So right now off the bat, he already has 9 season goals. All right, now, so that's 9 goals. What we don't know is how many goals he's going to score with the remaining games. So since we don't know something, we're going to put X, where X is goals in remaining games. It's a little sloppy. My bad. But how many games are left? 6. Because if you multiply the number of goals by the number of games he has left, add it to 9, we need to get 21. Now to solve this algebraically, subtract 9, and you get 12 equals 6x, divide by 6, and 2 equals x. If we go back, x is the goals in the remaining games, so therefore he needs 2 goals per game. All right. Again, this is the same way this is the same answer we got when we solved this logically. All we did was solve it with an equation. All right. Kids don't like equations. I'm not really sure why, because they think they're confusing. But when you think about it logically, it's the same thing as the math you've been doing for a very long time. You've actually been solving equations probably about since 4th or 5th grade, except you don't use variables. And that's one of the reasons why I don't understand why kids don't like math when variables come into play. But that's another story for another day. So if we look here, this was just an equation. We had 21 is the amount of goals for the record, equals 9 plus 6x. The only difference between this problem and the next one is a different slight change in the wordage. Okay? So let's go to this problem. And it's very, very, very similar. Again, Rob is trying to score the most goals of a single season for his soccer team. So far, he has 9 goals. Okay? And the single season record is 21 goals. If he just wants to break the record, and he has 6 games left, how many goals must he score per game to break the record? All right. So let's talk about this problem. And there's still 6 games left. All right. So we look at this, and we know he has 21 goals. All right. Then we know that we're going to have something here. But basically, you know that he wants to break the record. All right. So if we go back here, we know that in order to tie the record, he needs to score 2 goals per game. So if he wants to break the record, what he has to do is score more than 2 goals per game. So he has to score more than 2 goals. Because if we look at the same problem, so 20 minus 9 equals 12, divide that by 6 games, that'll give us 2. But if he scores 2 goals per game, he's only going to be at 21 goals. We know that he needs to break the record, therefore he needs to score more than 2 goals. This problem is an inequality. All because our solution set, not our answer mathematically itself dealing with the number 2, is different, but really what our solution is a lot different, because he needs to score more than 2 goals. If he scores 3 goals a game, if he scores 4 goals a game, if he averages 2.5 goals a game, he's still going to break the record, okay? And that's the whole idea behind inequalities. Instead of just having one singular answer, like an equation does, because when you solve the equation you get x equals 2, all right? You're going to get a lot more than one answer, because as long as he scores more than 2 on average, so 2.1, 2.2, 2.3, 3 goals, 4 goals, 7 goals, 1,000 goals, any of those numbers are going to be a correct answer in this scenario, because it'll give him more than 21 goals, which would be breaking the record. Okay? Now, the way that you set this inequality up is the same exact, almost, as to how we set up our equation. So again, we're going to have record needs to be less than number of goals. Okay? I'm going to write it in words because sometimes writing word problems out in words, or your equation in words, helps you write the word problem. So if you go back, the record is 21. We need the number of goals to be greater than 21. Okay? And the number of goals he gets for the rest of the season is the same as it was in our last equation, because it's 9 plus 6x. Okay? Now, let's see here. Solve this algebraically. So you subtract 9, and you get 12 is less than 6x. Divide by 6, divide by 6. And we get 2 is less than x, where x, goals per game. So in order for him to break the record, he must score more than, oops, I don't want to do that, more than 2 goals a game. All right, and that would be your answer. You need to score more than 2 goals a game. If you can follow this example, you can solve linear inequalities. That's all that's new. Nothing very, very major changes, except there's one more thing we have to do to our answer. Okay, so let's just go back to our first example. We knew that x was 2, okay, because all he had to do was score 2 goals. Now, when you solve the equations and you get x is 2, that's your final answer. We're done. If you have to label it, you label it, okay? The one thing we never make you do, because it's very basic, is graph your answer on a number line, okay? Because what values of x are going to make this true? Well, we always know that the answer for this problem is when x is equal to 2. So if you graph it on a number line, you're going to go to where the number 2 is, put a solid circle, because that's where we can have our answer, and that's that. X is equal to 2. All right. Now let's look at our answer. Let's look at our other answer when he wanted to beat the record. We had something where x was greater than 2. All right. So again, we have to graph this on a number line. But like I was saying before, our solution is going to be a little different. All right. Let's think of numbers. I'm actually going to extend this to help us visualize. So it goes to 4, 5, 1,000. All right, that's a lot of goals, but it's possible. Anything's possible. So if we look here, we know that x is greater than 2. So let's put some dots where x is greater than 2. So 3 is greater than 2, that's true. 5 is greater than 2. 3.5 is greater than 2. 1,000 is greater than 2. 4 is greater than 2. 2.5 is greater than 2. So if we notice, there's a lot of numbers that are greater than 2. Actually, since numbers never end, you can count forever and ever and ever, there's actually an unlimited amount of answers that answer the solution, as long as those numbers are greater than 2. The other thing, so I'm actually going to just shade in this entire portion of the line, because anything that my blue line is, that the blue shaded area is touching, is greater than 2. Okay? But there's one other thing we have to kind of think about and look at. All right? Because how do we know when we're going to stop? Because x can't equal 2. Because we already know that if he scores 2 goals per game, he's only going to tie the record. Nobody wants to tie it. Everyone wants to break the record. So really what we have to do is, what are we going to do at the number 2? Well, you have to think about it. Is if he scores 2.1 goals per game, that's still greater than 2. What about 2.001? That's greater than 2. What about 2.00001? That's still greater than 2. All right? So we can get very, very close to the number 2 on our number line, but we actually can't touch it. So what we're going to do is, at the number 2, we're just going to put an open circle to show that x can't be 2, x can only be greater than 2. All right? And that leads us into the different types of inequalities. So let's look at this. So we have solving linear inequalities. All right? So just like in our last problem, we gave you one example, and that was x was greater than 2. Let's think of some other scenarios where x is anything other than equal to 2. Well, we have x is greater than 2. The next thing we could have is x could have been less than 2. All right? X could have been greater than or equal to 2. All right? In our problem, that wasn't a possible solution because we didn't want to tie the record. We wanted to beat it. But you could have x is greater than or equal to 2. And then, likewise, you can have x is less than or equal to 2. All right? The way we read these, x is greater than 2. X is less than 2. X is greater than or equal to 2. X is less than or equal to 2. All right, and those are the 4 types of inequality symbols. All right, basically an inequality has an infinite number of solutions. All right, and the way you solve them is the exact same. It's actually the same exact way you solve an equation with 1 or 2 little extra steps. The main difference is that when we solve linear inequalities, you must always graph your number on an answer line. Okay, but really the number lines look very, very similar to one another. So again, I'm going to draw 4 number lines here. All right, and each one is going to be filled out the exact same. In the middle, you're going to put your, I like to call it our important number. And for all these inequalities, the important number is 2, because that's what our solution kind of is hovering around. And then you always want to put one number higher, the 3, one number less, the 1. All right. And the last step you always have to do is graph the solution on the number line. So like the one we did in the last example, we said x is greater than 2. So if you look, we can actually, one of the ways you do this is you can test a point. So the reason why I put a number above and number below is because let's test the number 3. Let's plug 3 in for x. 3 is greater than 2. That's a true statement, so we're going to shade whatever side 3 is on from our circle. And we put a open circle because x is greater than 2, but it does not say that x could equal 2. So that's why it's an open circle. Now, say we tested the point 1. We say 1 is greater than 2. That's wrong, that's false. So any number on the left side of 2, aka less than 2, is not going to make this inequality true, so therefore you must always shade to the right. if it's x is greater than a number. Now we go to here, x is less than 2. Again, we cannot actually equal 2 because we just want to be less than it. So if we plug a number in, 3 is less than 2. That is incorrect. Since 3 is on the right side, we're going to shade to the left. All right? Or what you could have done is just looked at your number line, known that 1 is less than 2, which is true, so you just shade to the left. You don't have to do both, because if it's true, if it's false on one side, it's going to be true on the other. But test one of the numbers. Number to the left, number to the right. So now here we have x is greater than or equal to 2. This is changing our solution set because we're allowed to have x equal to 2. All right? So we're going to put a solid dot on 2. And what number is greater than 2, 3 or 1? 3 is greater than, so we're going to shade to the right. All right. This would be if our example was saying that Rob wanted to either tie or beat the record, because then he could still average 2 goals a game, but if he averages more, he's beating the record. All right. Now, this is x is less than or equal to 2. So again, since there's equality, we can be equal to 2. We're going to put a solid circle at 2. 1 is less than 2, so we're going to shade to the left. All right. This is really what an inequality is. It's an answer to an equation that has more solutions than just one. In all the examples we've been doing prior to this in class, we're always getting like x equals 5, x equals 7, x equals 1, x equals negative 12, x equals 5 halves. But now we're going to be able to get a lot more solutions to our problems. And the fun thing about this is it really opens up the amount of questions or problems we can solve, because it gives us a lot more variations to problems, which you saw apparent in the first example where Rob just wanted to tie the game. We could only figure this problem out if we're solving equations, because you can only tie it scoring a certain amount of goals per game, which we found to be 2. But then when you said he wanted to beat the record, well, beating the record, there's an infinite amount of number of goals he can score. As long as he scores more than 2 a game, he's going to break the record. All right. I hope this video gave you a very good base on what solving inequalities is, and really what an inequality is at heart, because a lot of kids struggle with it, and I'm not exactly sure why, because it's just solving an equation, except your solution is different. Okay, there's a different meaning to your answer, and a lot of things you do in math, that's all that's changing, is what does your solution mean. All right. And as long as you read word problems carefully, you'll be able to pick out inequalities from absolute value from equations. So hope this video helped. If you have questions, let me know. I know this was a very basic video, but I really want to give you the concrete foundation of this topic, or else you really won't be able to solve many in-depth problems, and that's really what we want to get at. So if you have any questions, email me. Come find me, ask me questions. Hopefully you find this useful, and check out Derivative Dude.